we're going to be talking about polygons, which is Chapter 5, Lesson 4. Our learning goal today is that you can find the sum of angle measurements of a polygon and the measure of one interior and exterior angle of a regular polygon with the use of your notes. So first we're going to start off with some vocabulary. The first vocabulary word is a polygon. A polygon is a simple closed figure in a plane formed by three or more line segments. Example of polygons are triangles, quadrilaterals, pentagons, hexagons, so on and so forth. There are many different types of polygons that we're going to talk about this lesson. Our next vocabulary word are regular polygons. Regular polygons is a polygon that has all sides that are congruent and all angles are congruent. For example, a square. All sides are congruent, all angles are congruent. An equilateral triangle. All sides are congruent, all angles are congruent. Those are two examples of regular polygons. Our third vocabulary word is concave. Concave is a polygon where there are dents or indentations in it. When you think of concave, think it has a cave in it. For example, if I have a shape like this, right here is that makes it concave. And our last vocabulary word is convex, which is a polygon where there's no dents or indentations of it. If you haven't already, please copy down these vocabulary words and the examples onto your guided notes. Now we're going to use the chart on our guided notes to write in, to fill in all of the columns. So first we're going to talk about a triangle. The sum of the interior angles inside a triangle, the sum equals 180 degrees. The next column over, one interior angle of a regular polygon. If it's regular, all angles are the same, so we're going to take 180 degrees, divide it by 3. That means that each angle is 60 degrees. A picture would be just a picture of a triangle. We know that 180 degrees inside, so I'm going to notate that. And the sum of my exterior angles equals 360 degrees. The next shape is a quadrilateral. The sum of the interior angles, we add up all the inside angles, equals 360 degrees. Again, one interior angle would be 360 divided by the 4 angles we're given. That means each angle is going to be 90 degrees. A picture of a quadrilateral would be this. If it makes two triangles make this rectangle, which is 180 degrees and 180 degrees, which together equals 360 degrees. And the sum of the exterior angles equals 360 degrees. Make sure you're filling this in your chart. Our next shape is a pentagon. A pentagon has 5 sides. The sum of the interior angles equals 540 degrees. Okay, if we take that 540 degrees, divide it by the 5 angles it has, we get 108 degrees per angle. A picture of this there's a pentagon. If we wanted to break this into 3 triangles, we can. And we know 180 degrees in each triangle, which is why there is an interior angle sum of 540 degrees. Also, when you find the sum of the exterior angles, they always equal 360 degrees. Our next shape is a hexagon. The sum of the interior angles is 720 degrees. We're going to take that 720 degrees and divide it by the 6 angles that are inside the regular polygon. And we get a total of 120 degrees per angle, per interior angle. A picture of a hexagon will look like this. Let me try again. There's my picture of my hexagon. So I wanted to break it in triangles. There are 1, 2, 3, 4 triangles, each 180 degrees, which is why there is an interior sum of 720 degrees. And the sum of our exterior angles equals 360 degrees. Our next shape is a heptagon. Heptagon has an sum of interior angles, which is 900 degrees. We take that 900 degrees and divide it by the 7 angles that are inside the shape to find out that there is 128.57 degrees per angle. I'm going to pause this so I can attempt to draw this picture. There is my attempted heptagon. Now I'm going to break it into triangles. 180 degrees here, 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 and here, which if you added them up would give us the total 900 degrees of our interior angles. And the sum of the exterior angles, again, adds up to 360 degrees. Next shape is an octagon. An octagon has an interior sum of 1,080 degrees. If I take that number and I divide it by the 8 angles that are inside of an octagon, I get 135 degrees per angle. I'm going to go ahead and draw my octagon. Well, I'm going to try. There's my 8 sides. Okay? And the sum of my exterior angles equals 360 degrees. My next shape is nonagon. The sum of the interior angles add up to 1,260 degrees. To find this one interior angle of a regular polygon, I take that number, I divide it by how many angles I have, which is 9, and I get 140 degrees per angle. I am not going to attempt to draw a picture of a nonagon. If you would like to, be my guest. You can Google it if you'd like. We're going to move on to our last polygon that we're going to talk about, which is a decagon. There are a total of 1,440 degrees with all the interior angles added up together. If I take that number, divided by how many angles I have, which is 10, I get 144 degrees per angle. Again, I'm not going to draw this, but feel free to Google it and sketch it out on your notes. And the sum of the exterior angles equals 360 degrees. The last thing we're going to write on this page is we're going to talk about any polygon. Okay? If you look through the last few shapes that we've done, there is a trend that we see between finding the sum of the interior angles. If you take the number of sides of that polygon and subtract 2, and then take that difference and multiply it by 180, that will give you the interior angle sum. Remember, n is the number of sides. Okay, on the other side of the paper, in the top left corner, it says sum of interior angles. Go ahead and highlight sum of interior angles. And you are going to write the following. N minus, well, the difference between n and 2 times 180 degrees, where n is the number of sides. We're going to talk about a pentagon. Okay, we're going to break this into our 3 triangles like we talked about before. For this is 180 degrees, this is 180 degrees, this is 180 degrees, which we know 180 plus 180 plus 180 gives us 540 degrees. But now we're going to actually use the formula we wrote above. So n minus 2, the number of sides minus 2. Well, it has 5 sides. Minus 2 is going to be 3 times 180. 3 times 180 is 540 degrees. As you can see, we got the same answer both ways. Our example to the right of that says, what is the sum, well, you're going to write this down, what is the sum of interior angles of a polygon with 100 sides? So we're going to use our formula, n minus 2 times 180. Well, if it has 100 sides, I'm going to substitute that in for n. N minus 2 is 98. 98 times 180 gives us 17,640 degrees. So if we had a shape with 100 sides, all of the angles would add up to 17,640 degrees. On our next row down, it says interior angle measured for a regular polygon. We are going to find the measure of one interior angle. Okay, so first you're going to find the total angle sum using the equation we just discussed, n minus 2 times 180. Make sure you're copying these steps down in your notes. Number 2, then you divide that answer by the number of angles. Okay, this is to find the measure of one interior angle. So you're not finding the sum of all of them, you're finding the sum of just one of those angles. So now let's go into an example of this. Make sure you copy this down, pause if you need to. We're going to do 2 examples. We're going to talk about a heptagon and we're going to talk about a decagon. So for a heptagon, it has 7 sides. So I'm going to do 7 minus 2 times 180. I get 5 times 180, which equals 900 degrees is the sum of all of the interior angles. But I only want to find one interior angle. So I'm going to take that 900 and divide it by how many angles are in that shape, which is 7. I get 128.6 degrees per angle in my heptagon. In a decagon, which has 10 sides, I'm going to use my formula again. 10 is the number of sides, minus 2 times 180. 10 minus 2 is 8. 8 times 180 is 1,440 degrees. That's the sum of all of the interior angles. But I only want to know for one, so I'm going to take 1,440 divided by how many angles that I have in my shape, and I get 144 degrees per angle. My last 2 boxes on my notes say the sum of the exterior angles of a polygon equals 360 degrees. You need to write this down in your notes. One exterior angle for a regular polygon. One exterior angle. All exterior angles total 360 degrees no matter what shape it is or how many sides it has. So you first write the equation, and then you divide both sides of the equation by the number of sides to find one of the exterior angles. We're going to do an example. Make sure you copy this down in the left-hand box, bottom left-hand box. In the bottom right-hand box, we're going to do three examples: a pentagon, quadrilateral, and an octagon. For the pentagon, we're going to write our equation. So since the pentagon, it has 5 angles, so 5 times some unknown angle measurement equals a total of 360 degrees for the exterior angles. Exterior. I need to divide both sides by 5, and I get x is equal to 72 degrees. That means one exterior angle in a pentagon equals 72 degrees. For a quadrilateral, there are 4 angles. 4 unknown angles, so 4 times x equals a sum of 360 degrees. I divide both by 4, x is equal to 90 degrees. That means each exterior angle in a quadrilateral is 90 degrees. Our last example is an octagon, which has 8 sides and 8 angles. So 8 times x equals 360 degrees. We know all exterior angles total 360 degrees no matter what shape it is. Divide both sides by 8. I get x is equal to 45 degrees. That means that one exterior angle in an octagon is 45 degrees. Make sure that you have all these notes copied down onto your paper.